Welcome to today's deep dive. You know, when you just sort of sit back on your couch and look at your fireplace,
hmm
it is so easy to see the chimney as just like this static pile of bricks.
Oh, absolutely. It just gives off this illusion of being completely unchangeable. Like it's a monument that's just going to be there forever.
Right, like it's this heavy, permanent architectural feature sitting quietly right in the middle of your living room, basically just holding up the roof.
Right. But the reality is just completely different. Your chimney is not a static monument.
No, not at all.
It's actually a highly complex, honestly, incredibly vulnerable engine. And right now, whether you're actively using it or not, it is fighting this relentless two-front war against some of the most destructive physical forces in nature.
And we get to actually explore the mechanics of that war today.
Mm.
We're diving into some really incredible source material and expertise from Select Chimney Services, a team based out of Portland, Maine.
Which honestly is the absolute perfect proving ground for this kind of thing.
Oh, yeah. If you want to understand how a building survives, you don't look at a house in some, mild, perfectly temperate climate.
Right, you need a stress test.
Exactly. You look at a place with brutal coastal weather. I mean, Portland throws heavy seasonal rain, these biting winters, and relentless freeze-thaw cycles at these structures. It is the ultimate stress test for masonry.
It really forces you to understand the actual physics and the thermodynamics that are playing out right above your roof line. You can't just kind of hope for the best when nature is like actively trying to dismantle your home molecule by molecule.
Okay, let's unpack this, because it is dangerously easy to just completely ignore the chimney. I mean, think about it. We spent a whole weekend weatherizing the windows, right?
Oh, sure. Wrapping pipes, all of that.
Yeah, we wrap the exposed pipes. We call the HVAC guy to service the furnace every October like clockwork. But the chimney gets completely ignored until there's, like, literally water dripping into the firebox.
Or you get that freezing draft that just makes the living room completely unbearable.
Right. So today our mission is to break down the hidden physics of why chimneys fail, how water and extreme heat are secretly waging war on the structure, and, the very specific science behind how you can actually stop it.
And to stop it, we really have to move past this vague idea of just bad weather and look at the actual microscopic violence happening inside the brick itself.
The microscopic violence, I love that.
Yeah, it really starts with understanding the freeze-thaw cycle.
Especially in a really damp climate like Portland. I mean, you've got high humidity, coastal fog, heavy rain.
And that water doesn't just, wash over the surface of the brick like it would on a sheet of glass.
Right, because brick and mortar are essentially just hard sponges.
Exactly. They're incredibly porous. So water finds these tiny microscopic hairline cracks, and then capillary action just pulls the moisture deep inside the masonry.
Wow. And once that water is trapped inside the brick, you are entirely at the mercy of the thermometer, right?
Completely. Because when the temperature drops below freezing, that liquid water turns into a solid ice crystal. And the fundamental problem with water, well, the fundamental physics of it is that when it freezes, it expands by exactly 9%.
Which, 9% doesn't sound catastrophic until you realize where that expansion is actually happening. Wait, it's like leaving a closed can of soda in the freezer.
Oh, that's a perfect analogy.
Yeah, you put it in there to cool it down quickly, you completely forget about it, and you come back the next day to find the aluminum totally ripped apart.
Right, because the liquid has nowhere to go.
Exactly, so the vessel just gives way.
And that is exactly the mechanism happening here. The brick is your soda can. The ice crystal forms, it suddenly requires 9% more volume, and it literally pushes the rigid masonry apart from the inside out.
Wow.
We're talking thousands of pounds of pressure per square inch. It creates this tiny microscopic fracture, and then, a few days later, it thaws.
The ice melts.
Right, it melts, and it leaves a slightly larger cavity behind. So the next time it rains,
that larger cavity holds even more water.
Which then freezes, expands another 9%, and does even more damage.
Over and over again, compounding the destruction every single cycle.
Exactly. And this is why you start seeing what the industry calls spalling.
Spalling, right?
Yeah, it's the term for when the actual faces of your bricks literally pop off and just crumble into the yard. The structural integrity of the brick has just been completely shattered from the inside.
That's wild. And you also see, rust forming on the metal damper assemblies inside the firebox, right?
Rust is a huge indicator.
Or you might walk into your living room after a really heavy rain and notice that distinct sort of damp, musty odor. But there's another major visual red flag, which is efflorescence.
Yes, efflorescence is a massive warning sign.
I always see this on old brick buildings. It's those chalky, kind of white, powdery stains running down the side of the masonry.
Right, and people just think it's a surface stain. But it's not. Brick and mortar actually contain natural salts, so when water infiltrates the chimney, it dissolves those internal salts. And then, as the sun comes out and warms the brick, the water gets drawn back to the surface to evaporate, and it pulls those dissolved minerals with it.
Oh, I see.
So when the water evaporates into the air, it just leaves those white salt crystals behind on the face of the brick.
So if you see that white powder, it is undeniable proof that water is actively traveling through the entire depth of your structure.
It is basically a liquid highway running right through your living room wall.
Okay, so if external water is the ultimate enemy here, my first instinct as a homeowner is to just go down to the hardware store, buy a few gallons of heavy-duty exterior-grade elastomeric paint,
Oh boy.
and just paint the whole chimney. Create this thick, rubbery shell over the bricks and just lock the rain out entirely.
What's fascinating here is that painting exterior masonry is actually one of the worst mistakes a property owner can make.
Really?
Yeah, it all comes down to this concept called breathability. When you paint it, you're assuming that the only moisture attacking the chimney is coming from the sky. But homes are essentially these massive moisture generators.
Wait, you mean moisture from inside the house? Like just from us living in it?
Exactly.
Yeah.
Every time you boil a pot of pasta, take a hot shower, run the dishwasher, or honestly just exhale, you are putting water vapor into the air of your home.
Oh, wow. And because hot air rises, that humid air is traveling up through the house and interacting with the chimney structure.
Right. Plus, you have the combustion gases from the furnace or the fireplace itself. Those contain massive amounts of water vapor too. All of that internal moisture works its way into the porous masonry from the inside out.
Okay, I think I see where this is going.
Yeah, if you paint the exterior of the brick, you are effectively wrapping the chimney in a plastic bag. You might stop the rain from hitting the outside, sure, but you've also completely trapped all of that internal vapor.
The brick can't breathe.
Exactly. The moisture hits that impermeable layer of paint, condenses back into liquid water, and just sits inside the brick. So when January rolls around, that freeze-thaw cycle we just talked about, it destroys the chimney from the inside right behind the paint.
So we are in a total catch-22 here. We have to keep the driving rain out. We absolutely have to let the microscopic internal water vapor escape. I mean, I don't understand how a single material can possibly do both of those things.
It's tough. It requires highly specialized chemistry. Professionals, they don't use paint. They use vapor-permeable silane-siloxane waterproofing treatments.
Silane-siloxane. That sounds incredibly industrial. How does that actually work?
It's actually brilliant molecular engineering.
Yeah.
So unlike paint, which just sort of sits on top of the brick like a blanket, silane and siloxane molecules are small enough to penetrate deeply into the actual pores of the masonry.
Okay.
Once they're inside, they chemically bond with the silica in the brick and mortar. They alter the surface tension of the pores, making them intensely hydrophobic.
So when liquid water, like a raindrop, hits it, the water just beads right up and rolls off.
Exactly. It repels it. But here's the genius part. While the treatment prevents liquid water from entering, the chemical bond doesn't physically plug the pores. The microscopic gaps remain open.
Oh, wow.
And since a molecule of water vapor is significantly smaller than a physical drop of liquid water, that internal house humidity can still pass right through the open pores and escape into the atmosphere.
It's literally breathable armor.
That's exactly what it is.
But I'm guessing you can't just buy a spray bottle of this stuff and climb up on the roof yourself. The sources really emphasize that this is a highly rigorous professional process. You can't just spray expensive chemicals onto a crumbling brick and expect it to hold.
No, absolutely not. You have to prep the canvas, which requires some serious labor. It's a 5-step process.
Right.
The first phase is a meticulous inspection followed by cleaning. You have to remove decades of moss, algae, environmental grime, and biological growth.
Because all of that stuff is just holding moisture right against the brick.
Precisely. And then comes the actual structural repair, which usually involves tuck pointing.
See, I always thought tuck pointing just meant, like, smearing some new concrete over the cracks, but it's actually basically a surgical removal of the damage, right?
Oh, yeah. Smearing concrete over the surface is just a Band-Aid. It'll fall off in a year.
Mm.
Proper tuck pointing means a mason takes a diamond-bladed grinder and physically grinds out the decayed, sandy mortar joints to a very specific depth. Then they have to mix a new batch of mortar that matches the exact compressive strength and vapor permeability of the original historic block.
That is fascinating.
Yeah.
Because if you use a modern, like hyper-rigid Portland cement on an old soft brick, the cement will actually be stronger than the brick itself.
Right.
So when the chimney naturally expands and contracts with the seasons, that rigid dew mortar will literally crush the historic brick.
Exactly. The mortar is actually supposed to be the sacrificial element. It's supposed to be softer than the brick. So only after the damaged joints are ground out and perfectly repointed and the masonry is fully cured, only then do you apply that breathable siloxane sealant.
And even that isn't a permanent fix, right? The recommendation is to have the masonry inspected and potentially resealed every 3 to 5 years, depending on your local climate.
Yeah, 3 to 5 years is the standard.
I know someone listening is doing the math right now, right? They're thinking about the cost of professional diamond grinding mortar and applying advanced chemical sealants. Let's push back a bit. Is skipping this maintenance for a year or two really going to cause a structural collapse, or is it mostly cosmetic?
Well, it's the ultimate cost-benefit reality of home ownership. If you let that microscopic water damage progress, the mortar literally turns back into sand. The bricks completely lose their structural bond. And a chimney is incredibly heavy. When that structure weakens, it can shift. But honestly, before it even collapses, that water infiltration rots the surrounding roof decking. It travels down the framing and ruins your interior ceilings.
Oh man, so a few $1,000s in proactive tuck pointing and waterproofing is a fraction of the cost of tearing a roof off, ripping a massive brick column down to the foundation and rebuilding it from scratch.
It really is. It's the difference between buying a high-quality umbrella for your house every few years versus having to replace the entire structure.
So, okay, we've successfully armored the exterior, we've mastered the water and the ice. But the moment you strike a match in the fireplace, the entire physical dynamic flips.
It sure does.
We move from this external battle against water to an internal battle against extreme heat.
Which exposes a massive hidden danger, particularly for anyone living in a home built more than a few decades ago.
Yeah, let's talk about the inside.
Historically, chimneys were lined with these porous terracotta clay tiles. The smoke and the exhaust travel up through this clay corridor. And in some very old properties, there might not even be a liner at all, just bare brick.
But we just established that clay and brick are incredibly porous. They absorb moisture from the humid air, from the rain, from the house itself.
Right. So imagine it's a freezing Tuesday in January. The masonry of your chimney is bone-chillingly cold, and it's holding microscopic moisture.
Okay.
You decide you want to build a roaring fire in the living room. Within minutes, you are sending 1,000-degree exhaust gases up a narrow, freezing, moisture-logged clay tube.
Wow. That is the exact recipe for thermal shock.
Exactly.
It's like taking a glass baking dish out of the freezer and
Exactly.
immediately pouring boiling water right into it. The material just cannot handle the rapid, uneven expansion. The glass just shatters.
And that is exactly what happens inside the walls of your home. The rapid, violent heating and cooling cycle of regular fireplace use causes those rigid clay tiles to crack, shift, and literally crumble apart.
That's scary.
Yeah, if you look inside the clean-out door at the base of your chimney and you see flakes of orange clay, your liner is actively disintegrating.
And the implications of that are terrifying. The entire point of the flue liner is to be a sealed, airtight corridor to get toxic gas and stray sparks safely out of the house.
Right.
If those clay tiles crack and shift apart, you now have gaps. And right on the other side of those gaps is the highly combustible wooden framing of your attic and your interior walls.
The heat transfers directly to the wood. But, even more insidious than the fire risk is the carbon monoxide.
Let's talk about that, because I think a lot of people assume that since heat rises, carbon monoxide will just naturally float up and out the top of the chimney, even if there are some cracks. Why does it actually leak into the house?
Because a house is a dynamic pressure system. It breathes, you have exhaust fans in the bathroom, range hoods in the kitchen, and a furnace that's actively pulling air.
Right.
This creates what's called a stack effect, where the house can actually generate negative pressure in the lower levels. So if your chimney liner has a crack up in the attic, the negative pressure of your home can literally pull the toxic exhaust gases out of the chimney, through the wall cavities, and right into your bedrooms.
It acts just like a vacuum.
Exactly.
Which is why upgrading to a modern stainless steel liner is so critical.
Right.
Instead of a stack of fragile clay boxes, a professional will drop a seamless, corrugated stainless steel tube down the entire length of the flue.
If we connect this to the bigger picture, metal can expand and contract safely. It is completely impervious to thermal shock.
That makes sense.
It creates an absolute airtight seal all the way from the firebox to the chimney cap. But beyond just fixing the safety hazard, a stainless steel liner dramatically improves the appliance's overall efficiency.
Because it's cylindrical and smooth, right?
Yeah.
It maintains a much more consistent draft. The hot air spirals up faster and cleaner. But of course, that shiny new metal liner is completely useless if you allow it to get choked off by what is actually traveling through it. Which brings us to creosote.
Creosote.
Cool.
Yeah, it is the unavoidable, highly flammable byproduct of burning wood.
Right.
When you burn a log, it releases unburned particulates, tar vapors, and moisture. As that smoke travels up the chimney, it hits the cooler upper sections of the flue. The gases condense on the walls, and they leave behind this sticky brown or black residue.
And over time, as that residue bakes from the heat of subsequent fires, it hardens into a thick, highly combustible glaze. And the sources note that this creosote physically narrows the interior of the flue. It makes the opening smaller and smaller.
Which fundamentally alters the thermodynamics of your fireplace. See, a fire needs a massive amount of oxygen to burn hot and clean.
Okay.
The chimney operates on a draft system. The hot air rising pulls fresh oxygen into the firebox. When creosote restricts the diameter of the flue, it chokes off that airflow.
Here's where it gets really interesting. There is a paradox here that I just need to understand. Creosote is highly flammable. It is literally baked tar. But a chimney choked with flammable creosote actually results in a colder fire in the living room.
Yeah.
How did the buildup of fuel make the fire less hot?
It's all because of the combustion triangle. Heat, fuel, and oxygen. You have plenty of fuel, but you have choked off the oxygen.
Oh, I see.
Without sufficient oxygen being pulled into the firebox by a strong draft, the wood cannot achieve secondary combustion. It simply can't burn hot. So instead of a vibrant, heat-producing fire, you just get this low-temperature smolder.
And a smoldering fire produces massive amounts of smoke.
Which then condenses into even more creosote. It is a vicious, accelerating cycle.
And this ties directly back to what we were talking about earlier with waterproofing the exterior. If your masonry joints are destroyed and the brick is soaked with water, that chimney basically acts like a giant thermal battery, but in reverse. It is holding freezing temperatures right against the flue liner. The exhaust gases hit that freezing zone, condense immediately, and just dump creosote at an alarming rate.
A compromised exterior practically guarantees a choked interior. And the only way to break the physical chokehold of hardened creosote is through a professional sweep.
Yeah, you can't just DIY this.
No, a homeowner with a plastic brush from the local hardware store cannot dislodge glazed stage 3 creosote. It requires professional rotary chains and chemical modifiers to actually break down that baked-on tar.
The insurance industry is completely aware of this hazard, too. I mean, if you have a chimney fire, which, by the way, sounds like a jet engine roaring inside your walls,
Yeah.
and the insurance adjuster finds that you haven't had documented professional sweeps to remove that creosote, they can deny the claim entirely.
Because a chimney fire is 100% preventable. It only happens when you provide the fuel, the creosote, and completely ignore the maintenance.
So we've covered the exterior armor, the internal pressure dynamics, the thermal shock, and the thermodynamics of draft. But the chimney doesn't exist in a vacuum.
No, it doesn't.
It is part of the larger ecosystem of the house. And one of the most surprising factors in chimney failure has nothing to do with the masonry or the fireplace at all. It's your gutters.
It sounds completely unrelated, right? But the roof drainage system is really the frontline defense for the entire house. A typical roof sheds thousands of gallons of water during a heavy rainstorm.
And in a place like Portland, you are dealing with autumn leaves, pine needles, and ice dams. When those gutters clog, all of that heavy seasonal rain and winter snow melt doesn't just, neatly drop to the ground. It finds the path of least resistance.
Which is often cascading right over the edge of the gutter and dumping a continuous waterfall directly onto the masonry of the chimney.
Wow. So you could have perfectly ground tuck pointing, a flawless application of silane-siloxane, and a brand new stainless steel liner. But if your gutters are just dumping hundreds of gallons of water directly onto the chimney face, you are completely overwhelming the physical limits of the waterproofing.
It perfectly illustrates why home maintenance requires a truly holistic approach. You can't just fix a cracked brick and completely ignore the broken downspout 2 feet above it. True protection means pairing internal stainless steel liners and exterior masonry repair with flawless roof drainage.
So what does this all mean? It's a total domino effect. It is wild to think that Skipping the annoying Saturday chore of cleaning wet leaves out of your gutters in October could eventually result in carbon monoxide leaking into your bedroom in January.
It's all connected.
Yeah, the overflowing gutter soaks the brick, the freeze-thaw cycle shatters the mortar, the cold chimney produces excess creosote, the draft fails, and the house pulls the toxic gas through the compromised structure.
This raises an important question, really. It shifts how you have to view the building you live in. You have to ask yourself if you are just treating symptoms like wiping up a puddle or complaining about a draft, or if you are actually addressing the root causes of systemic failure.
Which brings us right back to where we started. Your chimney is not a static pile of dead bricks. We've seen how water, freezing inside microscopic pores, exerts thousands of pounds of pressure to tear masonry apart. We've learned that a house generates internal vapor that must be allowed to breathe through advanced chemical sealants, not suffocated by paint.
Right.
We've explored the violent physics of thermal shock as shattering clay tiles, and how a choked flue literally starves a fire of the oxygen it needs to survive.
And, while the brutal weather of the Northeast provides the ultimate case study for us today, the physics of water expansion, thermal shock, and pressure dynamics apply to every single home in every single climate. Ignoring them is just a guarantee of structural failure.
We constantly think of a house as a static shelter. We just assume it is this permanent box meant to protect us from the elements. But when you really look at the physics, the very elements we use to make a house a home, the fire we burn for warmth, the water we use for life, are the exact same physical forces constantly trying to tear the structure down.
That's so true.
Your home is a living, breathing, expanding, contracting machine. So as you look around your own living room, what other static parts of your house are secretly battling unseen physical forces right now?